For this presentation, we'll be exploring simplifying complex fractions. So what is a complex fraction? A complex fraction is when you have a large fraction where you have actually fractions in the numerator and in the denominator. There's going to be two methods for simplifying this, but as you see, this is kind of complicated, and our goal is going to be to make this just a traditional looking fraction, like something like 10 over x, so, something kind of more traditional, where you have a single number or a single term or polynomial over another polynomial. All right, so for method one, the idea is we're going to treat this large division bar in the middle as well, or fraction bar in the middle, as a division. So in other words, I'm going to look at this as 2/3 divided by 5/6. Well, one of the things about division is really dividing by something is the same thing as multiplying by its reciprocal. So instead of looking at this as 2/3 divided by 5/6, let's look at this as 2/3 times 6/5. Remember, the reciprocal of a number is you just flip it over. So 2/3 times 6/5, the 6 and the 3 will cancel to give you 2, so we're just left with 4 over 5. All right, for method two, by the way, with method one, sometimes it's not this simple, because if we have multiple fractions in the numerator and the denominator, like we have over here, you're going to have to combine these first into a single fraction over another single fraction before you can do the flipping thing. For method two, this one will always work like right from the start. You don't have to do any kind of prep work for it. But for this, we need to look at the top and look at the bottom of our big fraction and find the LCD of every term that we see. So here we have a 3, here we have a 6, so the LCD would be 6. Next, we just multiply the numerator and denominator by that 6, and I'm talking about the numerator and denominator of the big fraction. Well, 2/3 times 6 just gives you 4, and 5/6 times 6 just gives you 5. So therefore, our answer would just be 4/5. All right, so let's explore some harder examples. And again, either method will always work. It's a matter of choice. But often you'll want to choose a method that looks simpler. In other words, I prefer method one when I have a single fraction over another single fraction. And I prefer method two in every other situation. But it's really just a matter of choice. All right, so let's work on this one. Let's simplify 1 over x minus 1/3 divided by 1 over x plus 1/3. And just for illustrative purposes, I'm going to use both methods here. But my personal preference for this one will be method 2, and you'll see why. All right, so for this one, right, let me just rewrite the problem. Take out the pen. All right. Sorry about that. All right. So we have 1 over x minus 1/3, all of that divided by 1 over x plus 1/3. And again, even though I prefer method 2, I'm going to use method 1 over here. And the idea behind method 1 is we need to have a single fraction on the top and a single fraction in the denominator. So let's do that. Well, to make this a single fraction in the numerator, we need to find the LCD of the numerator, which would just be 3x. So I need to make each of these things a 3x in the denominator. So one way I can do that is I can take this and multiply it by 3 over 3. And I can multiply this one by just x over x, because that will make the denominators 3x. And I can do the same thing over here. The denominator, the LCD of this denominator here is also 3x, just coincidence. Okay, so just do the same thing. So now let's try to rewrite this. So we have, let's see, 3 over 3x minus x over 3x. All of that divided by 3 over 3x plus x over 3x. Next, we need to write this as a single fraction on both the top and the bottom. So because the whole point of finding these common denominators is because then we can just add the numerators. So now we just have 3 minus x over 3x, all of that divided by 3 plus x over 3x. Well, since we now have a single fraction over another single fraction, we could treat the large division bar as a division. So in other words, we have 3 minus x over 3x divided by 3 plus x over 3x. But instead of looking at this as division, we can just treat this as a multiplication of the reciprocal. So in other words, we just need to flip over this last one and change the division to a multiplication. So let's do that. So let's rewrite this. So we have 3 minus x over 3x. I'm just going to take the first thing as it is, and then multiply by the reciprocal. Let me write it as a multiplication symbol like that, the circle. So the reciprocal of 3 plus x over 3x is just going to be 3x over 3 plus x. Okay, so now these 3x's will cancel, and we're just left with 3 minus x over 3 plus x. And this doesn't simplify anymore. We're done. So this was a lot of steps, and this is why I actually prefer method 2. The way method 2 is going to work, all right, so for method 2, what we're going to do, let me rewrite what we had. We had, let's see, 1 over x minus 1/3, all of that divided by 1 over x plus 1/3. Well, looking at all of our denominators, the LCD of all of those will be 3x. So I'm just going to multiply the entire top by 3x and the entire denominator by 3x. And then I just need to distribute. So let's do that. Well, 3x times 1 over x, well, let's see, the x's would cancel and you'd just be left with 3. 3x times 1/3, well, the 3's would cancel and you'd just be left with x. Doing the same thing as denominator, 3x times 1 over x, the x's would cancel and you're just left with 3. And then 3x times 1/3, the 3's would cancel and you'd just be left with a plus x. And as you see, for this one, I definitely prefer method 2. It was only like one step and then you're done. And you might have to simplify more here, but we're done at this point. For this example, we don't have to simplify anymore. All right, or we can't rather. Let's do this one. So for this one, we have actually, it's a little ugly looking, granted, but we actually do just have a single fraction over another single fraction. Since I have that, I prefer to use method 1, so let's do that. So I'm going to use method 1 over here just because that's what I prefer for a single fraction over a single fraction. So let's do that. We have x plus 5 over, you know what, let me factor that. X squared minus 16, that's a difference in squares, and that's going to give you x plus 4 times x minus 4. At any point in time you can factor, it's okay. And then I'm going to divide that whole thing by, let's see, again, this will factor to be x plus 5 times x minus 5 over x minus 4. Okay, since I'm using method 1 and I already have a single fraction over another single fraction, I can treat this like a division. And honestly, normally I skip this step. I just do it in my head, thinking this is division. But I recommend for your first few times you actually write out this step. So in other words, this top, the x plus 5 over x plus 4 times x minus 4, is being divided by everything in the bottom. And everything in the bottom is just x plus 5 times x minus 5 over x minus 4. Okay, at this point, be careful not to simplify anything. You don't want to simplify at this stage. All you want to do is flip over this. So we're going to flip over this one and change this division to a multiplication. All right, so let's do that. So we have x plus 5 over x plus 4 times x minus 4. And again, you're going to leave the original fraction alone. Then we have a multiplication. We need to, but again, since we're making a multiplication, we need to flip over, do the reciprocal of the second thing. So let's do the reciprocal. We have x minus 4 over x plus 5 times x minus 5. Okay, does anything cancel here? Well, yes. Let's see, here we have an x plus 5 that can cancel out with this x plus 5. And remember, you can only cancel out factors, and so we're done with that. All right, here's an x minus 4, here's an x minus 4, those cancel. And again, when these cancel, they're canceling to be 1. So on the numerator, we just have 1. And in the denominator, we just have x plus 4 times x minus 5. All right, and we're done with that problem. All right, let's try another one. So this is actually the one we started off with by looking at. We have 1 minus 9 over x squared divided by 1 minus 1 over x minus 6 over x squared. Since we have multiple fractions in both the top and the bottom, I prefer to use method 2. And again, that's my preference, but I kind of recommend you stick with that as well. So what we're doing here is we have a whole bunch of things. We have, let's see, let me rewrite this. We have a 1 minus 9 over x squared. All of that divided by 1 minus 1 over x minus 6 over x squared. So again, I'm going to look at every denominator. And even these numbers in front technically have denominators, but they're just 1, so we don't really need to pay attention to that. So looking at x squared, x, and x squared, the LCD would be x squared. So let me multiply the whole top by x squared and the whole bottom by x squared. And then we can distribute. So the top would then just become x squared minus, well, x squared times 9 over x squared. Those x squareds would cancel, and you're just left with minus 9. In the denominator, I'm going to do the same thing. So we have x squared minus, well, x squared times 1 over x just gives you x. And x squared times 6 divided by x squared, the x squareds will cancel, and you're just left with minus 6. Okay, so we simplified the complex fraction, but we didn't simplify it all the way, because looking at both the numerator and denominator, both of those factors, so maybe one of those factors might cancel. So in the numerator, we have a difference in squares, so it's going to factor to be x plus 3 times x minus 3. And then in the denominator, this will factor to be x minus 3 times x plus 2. Okay, does anything cancel here? Well, yeah, we have an x minus 3 in both. So that's going to be our final answer. It's just going to be x plus 3 over x plus 2.